Good morning.
Good morning.
Good morning, sir.
Okay, so So this is the code to join peer deck. So by uh, on your phone or laptop, kindly enter this joinpd.com, and after that you will face the code. This code will be TIIPMF. Okay, so kindly join it first. Okay, two are connected. Five. There are only 11 participants. So how many of you have completed the syllabus of week 11 up to week 11? Hello.
Sir, just half till now.
Okay. There is only one topic, right, in week 11 by binomial and
Yes, sir.
binomial distribution. I think that is an easy one topic also. So there are 12 participants. Let's wait for a couple of seconds. After that, we will continue for this, right? So that more people can join.
Sir,
Yeah, please.
sir, is Anthem is going to reschedule?
I don't think so. What is the date? I think it's on
3rd April, sir.
3rd of April, right?
Yes.
I don't think. If is there any notification regarding that?
No. Actually, some the students having the collapse with the other paper, na degree paper.
Okay. So if it will happen, then you will notify it. Actually,
Okay.
I'm not sure about the
So till now, no update is there.
no.
Okay.
So, okay, so this is solve with session for week 11, which contains the concept of binomial distribution. So all of you are very familiar with this peer deck session. Kindly keep a notebook and pen ready for solving the problems. Okay, and you will provide for 5 to 10 minutes according the level of the questions. And you are familiar with how to enter the answer, right? And now And who have not joined this peer deck, kindly join this by entering joinpd.com. And after that, you have to enter this code, top right corner code TIIPMF. Okay. So I think we can start. Yeah, see, there is some tip to solve the question. Actually, you know the concept of binomial distribution. Okay. Uh, can anyone tell me what is the purpose behind the binomial distribution? How binomial distribution come? Anyone?
If a random experiment has
Mhm.
two outcome like success and failure,
Okay.
and all the experiment are independent to each other, like I have done the experiment 5 times, same
Okay.
experiment, and
Mhm.
it is independent to each other, then
Yes.
it's a binomial distribution.
Yeah. Actually, binomial is something which are you familiar with the Bernoulli trial?
Yes,
Bernoulli trial is something uh, in which each trial has two possibilities, either success or failure,
or failure.
right? And when when you have n Bernoulli trials, when you add the n independent Bernoulli trials, then it will take the form of binomial distribution,
Yeah,
right?
right.
In Bernoulli, you have suppose one trial which outcome is either success or failure, right? And probability of success is suppose p, and probability of failure will be 1 minus p, because sum of the total probability is 1.
Yes,
But in binomial is something when you try for an independent trials, right? And each trial is independent and identically distributed. See in the slides, if you see, independent trial means each of the trial is independent of the other trial. Means suppose you roll a die. Okay.
yeah,
Suppose you roll a die 2 times, then rolling a die first time is independent of the rolling of the second time. An identical trial means is something when the probability of success is same for each of the trial, right? Identical
right,
means same. Okay. So if this all the properties satisfied, then it becomes the binomial distribution. When your each trial is each trial is outcome of each trial is like success or failure, with probability, success probability you can say p, or failure probability you can say 1 minus p. Then and if you add the n independent Bernoulli trial, it will take the form of the binomial distribution. Okay. And there is a tip like given an experiment, look whether we can classify each trial as success or failure. Now it's clear to everyone. Till this point it is okay to everyone.
Yes, sir.
Yeah. Okay. And also then check all the trials are independent or identical. If both conditions are satisfied, then it is a binomial experiment. And after that you have to apply the concept of binomial distribution, whatever it is. Okay.
Sir.
Yeah. Yeah. Yeah, please.
So basically, the difference between the binomial and Bernoulli is, in Bernoulli there is a one trial, and in this
See,
binomial there are n
Bernoulli.
number of trial.
Yeah, Bernoulli trial is something. Suppose I say I toss a coin and it's a Bernoulli trial. Bernoulli trials means for that trial you will have two outcomes, success or failure. Okay. Suppose tossing a coin I repeated 5 times,
Yes, sir.
then it will take the form of binomial.
Okay.
Okay.
Okay, sir. Got it.
Got it. So yeah, this is the question one in which you have to find the out of these experiments which are binomial or not, which one is binomial or not. So read this and attempt this for this. To attempt this question, just keep in mind the properties of binomial distribution, which I have discussed in the previous.
Done, sir.
Okay, nice. Let's wait. There are no 22 responses. Let's wait for a couple of seconds. After that, we will see the solution. Okay, I think I can see the responses. Okay, 18 people with third option, and yeah, see. Anyone can tell me why third option is not a binomial experiment? Third is correct option. I mean,
Yeah.
for this question, third is correct.
Because it does not have two options. Like it does not have two outcomes. It can have more outcomes.
Why you can?
No.
No.
Third
You have
option
two
is
options.
Independent,
You
sir.
you can choose 5 ball or not choose.
Sir, choosing a wall is not the independent.
And
actually
for
each.
First experiment will, second experiment will depends on first.
Yeah,
yes,
these are not
and if you
independent.
see in the third option, it is clearly mentioned that 20 yellow balls and 20 red balls without replacement. Suppose you did the things without replacement, in that case probability will not be same.
Okay.
Okay, and in
Yeah.
the binomial, probability for each trial should be same.
Okay.
Sir, if a replacement given, then
Then it will be, it can become binomial.
okay, okay.
Okay, because suppose I draw one yellow ball, then what will be the probability? 1 by 20. Sorry.
Yes, sir.
Okay, suppose 1 by 20. Suppose I draw the second yellow ball, then it will be 1 by 90.
Yes, sir.
Okay, then that means your probability becomes changing. But in binomial case, probability should be same for each trial, right?
Yes, sir.
That's why the third is not a binomial experiment. Solution is there means in the for first, see, for the binomial condition is something, each trial should have either success or failure as outcomes. N is fixed and all trials are independent and identical. If you see in the experiment one, your N is fixed, right? And for each trial, if you get head as success, then tails will be as failure, right? And for each, see, coin is unbiased means probability of getting success, probability of getting tails or probability of getting head is half. And if you see probability half is will be same for 100 trial. Means you do the first trial, then for each means getting tail and head, probability is half. You did the second trial, probability is half. You did the third trial, probability is half. Kind of up to 100 trial, you will get the same probability, right?
Yes, sir.
It's clear to everyone?
Yes, sir.
Yeah. Then move for the experiment 2. In experiment 2, if you see n is fixed, but in the experiment 2, you see coin is not unbiased, it's biased. Biased means probability is some probability is not half. Unbiased means type of fair things, means half of for head, half of for tail. And unbiased, sorry, biased means suppose 0.3 for head, 0.7 for tail, but 0.3 will be same for each trial. Okay, then in this case, its probability is taken as C. So C will be same for 100 trial. That's why each trial is independent and identical also, and probability is same. That's why it's again a binomial random variable. Now, if you go for the third experiment, if you see, suppose you get the red ball as success, otherwise getting yellow ball is failure, right? So outcomes is like success or failure. But if you see the probability for first trial, so probability of getting red ball is 20 by 20 plus 20, that is half.
Yes, sir.
If you did see n is 5 means you have to do 5 trial, and if you go for the second trial, then probability is changed 19 by 39. So here probability become different. So each trial is not independent. Okay, and you know the meaning of identical. Identical means probability for each trial should be same. So that's why it's violates this property. Then it is not a binomial experiment. Is it clear to everyone? Concept of binomial distribution
Yes, sir.
experiment.
Got it.
Got it?
Yes, sir.
Okay. So let's move for the next slide. See, this is something step two, how to solve the binomial. Previous one was to identify the binomial experiment. How you can identify. This is the step. You know the PMF for the binomial, right? This is the that thing. Means calculate the P first. See, suppose in this PMF, if you see probability of x equal to I is nothing but NCI P raised for I 1 minus P raised for n minus I. What is n is here?
Trials.
Number of trials. P, what is P?
Probability.
Success probability. Okay.
Yes, sir.
And 1 minus P is the failure probability.
Yes,
Right?
sir.
And x equal to I means the I, your I will take the value 0 to n. Means suppose x equal to 0 and x equal to 1. What will be the probability for x equal to 1? What will be the probability for x equal to 2? Then I will replace accordingly whatever we are trying to find. Right?
Yes, sir.
Now it's clear to everyone. Means see, first you have to find that experiment is binomial or not. If it's binomial, then you have to find the success probability. After that, apply the PMF formula to finding the probability.
And choose I means NC I, na?
Yeah, NCI.
Okay.
Okay. Is it clear to everyone?
Yes, sir.
I'm not getting the response from everyone actually. Hello, is it fine to everyone? Till now, it's clear.
Yes, sir. Please carry on.
Yes, sir.
Okay.
Yes, sir.
Okay.
Yes.
Yeah. Yeah. This is the something you can think, and I think 6 to 7 minutes more will be more than enough. Just try to find what can be the success probability there. You know how to, what is the meaning of, suppose I'm saying, arrow lands on, specific region on that circular board. So suppose the area where which, arrow lands on that circular board will be directly proportional to the area of that region. Okay, and you know the area of a circular, right? I'm asking, you know the area of circular.
Yes, sir.
IR square.
Okay, then yeah, please proceed. I think we can go for this solution, right? Hello, am I audible?
Yes.
Okay, 0.1. I see. Can you tell me how how
Sir, actually, I found out the probability of hitting the target. That would be 1 by 16.
1 by 16? Why?
Based on the area, sir. The total area is pi r square. That is pi into 20 times 20. And chances of hitting is like pi into 5 into 5. So the probability would be 1 by 4 into 1 by 4, which is 1/16.
Okay.
And after that, I use the binomial that formula. N choose I. I took I as 2. And for that, I got 15 out of 4096. And then someone like a student could also hit it three times. So that would be 1 by 16 three times. Multiplied 3 times.
Yeah. It's right. Actually, what was my purpose? See, are you able to find, and identify the binomial, right?
Yes.
But if you see in the question, it clearly mentioned that if the student shoots an arrow in the region of radius less than 5 meters, then it will be considered a success, otherwise it will be failure, right?
Yeah.
And probability is same. See, if in the question, if you see, it's mentioned that assume for a normal student, there is an equal chance that arrow will land anywhere on the board. That means probability will be same. That's why it became the binomial distribution, right?
Okay.
Now, okay, if you see, it will be yeah, you are right. I think you got the 0.0625, right? See,
Yes, sir.
yeah, total area, pi r square, that will be pi 20 square, that means 400 pi, right? And success means what will be success? Success is area on the circular board which will lead to success is less than 5. That means pi r square, that means 5 pi 5 square, that will be 25 pi. Is everyone getting this point or not? Suppose this is circular board, okay, of 20 meter, and suppose I'm taking this. This is this green area is something. Green circle is something which radius is less than or equal to 5, right? And suppose this black one is something which is 20 meter, radius. Radius of circle of 20 meter radius, right? Is it okay? Hello.
Yes, sir.
So what will be the total sample space here? Pi r square. That means pi into 20 square, which will be 400 pi, right?
Yes, sir.
And what is the success? If you see in the question is success is something if the student shoots an arrow in the region of radius less than 5 meters. Okay. What is success? If student suppose arrow is lands on here, so success will be for anywhere in this green region, right?
Yes, sir.
Okay, you getting this point?
Yes, sir.
Okay, so what is success is something, suppose arrow is lands on here, then it is approximately, proportional, it's equal to proportional to that region. Suppose arrow lands on here, it will be proportional to that region. So for this green region, what will be the area? Pi is r square, and r is something which is less or equal to 5. That means 25 pi, It can be anywhere of this region, right? So what will be your success probability? Anyone?
Ratio of
160.
these two areas. Ratio of these
25
two.
pi by 400 pi.
That's it.
1/16.
1 by 16 or 1 by
400, sir.
400.
20 into 20.
That's 400.
20.
oh okay.
Denominator.
Okay. Yeah. It will be 1
1
by
by
16,
16.
right?
Yes, sir.
That is your success probability. Okay. Now, in the question, if you see, we have to find the probability that normal student will pass the test. And when a student will pass the test, in that case, if he
At least two success.
undergoes 3 trials and he needs to at least 2 successes, that means probability x greater or equal to 2 you have to find. Okay.
Yes. Yes.
So probability of success is this one, and probability of failure, I mean 1 minus p will be 1 minus 0.0625, right? And you have number of trials, how much?
3.
Which is nothing but 3. And you have to apply the probability x equal to I, which is NCI p raised power I 1 minus p raised power n minus I. Okay. See, and what is the meaning of at least 2? See, you have
Minimum 2,
probability x equal to I NCI p raised power I 1 minus p raised power n minus I. Okay. You have to find at least 2. That means this one. That means probability x equal to 2 plus probability x equal to 3, right?
Yes, sir.
And how you can find this one? 3C2, your n is 3 in total. Okay. And p 0.0625, if I'm not wrong, it will be 2. 1 minus 0.0625 raised power 1 plus, for this one it will be 3C3. See, I is 3, right? And n is 3. Okay.
1.
And 1 minus 0.0625 raised power 0.
3, 0.
0, because it will be n minus I. So 3
Yes,
minus
sir.
3 will be 0. Here
Yes.
3 minus 2 will be 1, right? And after that you will get the required answer. Yeah, that is the correct answer. Okay. This question is clear to everyone?
Yes, sir.
Okay. Now move further.
हाँ तो मैं बोलती क्या होगा?
See, now suppose you got mean, variance in the question, and in that case, how you can calculate the required values. Okay. See, first step is identify the binomial one, and
Sir?
the please.
In first previous question, can we take x is equal to 1 also? 1
Why?
and 2?
Why you will take 1 and 2?
Actually, at least 2 trials.
Yeah.
Required.
See, for example, you have 5 trials, right? I'm
Yes,
saying
sir.
at least 2 must be cleared. Means at least 2 must be clear, means 2 must be clear. More than 2 can happen also.
Okay.
Okay. At least suppose you are here, that means you have already cleared these 2 tests. Means you have cleared 2 tests.
So in at least actually both the remaining trial he should succeed.
Yes,
Otherwise
yes.
he will not pass.
Yeah. Suppose you have 3 trial and you must pass the at least 2. Means you must pass the first one, means, and second one, and then this one.
Okay.
Okay. Yeah. And the formula of binomial random variable. Expectation of x is NP, and variance of binomial random is NP into 1 minus P. Okay, where it's nothing but just a description. N is the number of trials, P is the probability of success, Q is the probability of failure. Okay, and use the equation of expectation. And suppose I have given the values of expectation and variance, and ask about the constant, means value of N and P. Then you can solve for the N and P, right? See, how mean and variance came of binomial. What is mean of expectation for Bernoulli? Anyone?
Equal to probability.
Equal to P. And for variance?
P into 1 minus P.
And suppose xi is your Bernoulli random variable. Okay.
Yeah.
And sum of n Bernoulli random variable is the binomial.
Yes, sir.
Okay, suppose your x is here, x become binomial, and these x1, x2 up to xn are Bernoulli random variable. Okay, means suppose you toss a coin for n times. So for first time, for first trial, okay, it will be Bernoulli head or tail. And for second trial, it will again become Bernoulli head or tail, and similarly up to n trial. If you add these all things, it will become the binomial random variable. Okay, and for each Bernoulli trial, mean is P, right? Suppose I'm saying, what will be expectation of x here? Expectation of x is nothing but expectation of x1 plus x2 plus so on up to xn, right?
Yes.
You can write it as expectation of x1 plus expectation of x2 plus so on expectation of xn, right?
Yes,
and
sir.
the expectation of x1, what is this? P plus P plus P and so on up to n times. So it will become the NP. What is this? Expectation of binomial random variable.
Yes, sir.
Okay. Similarly, the variance for. So what will be this? Variance of x1, x2 up to xn. And these all are independent. Okay. Then variance will came the inside. Okay. And what is the variance of this?
P of P minus 1.
P into 1 minus P.
1 minus P plus P into 1 minus P, so on, plus P into 1 minus P. Okay.
So n times.
Yeah. Then it's n P 1 minus P, which is variance for the binomial random variable.
Binomial.
Now it's clear?
Yes, sir.
Okay. So yeah, this is the question. So you have given the mean, variance, and expectation, and you have to find the probability of getting 3 tests. So you have 5 to 6 minutes. Solve this.
Variance and expectations.
Yeah, hello. Are you able to understand this question, right?
Yes, sir.
Perfect.
Yes, sir.
Remaining people are trying, or there are only 17 responses. Hello. Hello, am I audible?
Yes, sir. Audible, sir. We can
Yes,
move to
sir.
the answers.
Okay, okay, one second. So let me see the responses first. Actually, there are all of you are not trying. Actually, there are only 18 responses. Kindly solve with us. Actually, you will get better idea if you solve it. Okay, 0.308730. Okay, near about same. Okay, see what you what you get the concept behind this question means variance and expectation is given, and you have to find the probability of getting 3 tail, right? So what was the first approach? Anyone? How did you approach this question?
Finding P.
Finding P. How you have find this?
V of x is equal to E of x into 1 minus P.
Okay, see Ex of is given and P, and variance of x is given. Okay, this is what is this value? This one is 3.5 and 1.05. Okay, right? So these two things have to given to you, and by two equations you can find the two values of two variables, right? And so can you tell me how you can find here a value of anyone, means of n or p?
We put value of NP in variance equation and then we will find value.
Yes, you can put it. Okay,
Yes, sir.
that means it will be 1 minus p equal to 1.05 divided by 3.5.
Yes, sir.
Okay, then you will get p equal to 1 minus 1.05 divided by 3.5.
Yes, sir.
And what was the value of p here?
0.7.
Yeah. See, this is the same which I have did. See, mean is given, variance is given. Okay, and the expectation of binomial is np, which is 3.5, and variance of a binomial random variable is np into 1 minus p, which is 1.05. And if you divide these two, you will get the p equal to 0.7. Okay, and in the question, see, you get the success probability, which is nothing but 0.7. And in the question, your n is given. Sorry, you have to find the n. Okay, if your p is 0.7, okay, if you put this value in this first equation, then you will easily get the value of n. Okay, 3.5 divided by 0.7, your n will be 5, right?
Yes, sir.
It's clear to everyone. And you can verify your n is 5, p is equal to 0.7, then your np will be 3.5, means 5 into this one. So you get the success probability p, which is 0.7, and as 5, and you have to find the probability of getting 3 tails in 5 tosses. So p x equal to 3 will be 5c3. Success probability means p raised to power 3, which is nothing but 0.7 raised to power 3, and 1 minus p raised to power n minus I, which is 5 minus 3, which is 2. And if you solve this one, you will get this. It's clear to everyone?
Yes, sir.
Yes.
Okay. Now you are able to how to identify the binomial, how to find the probability for binomial, how to find the expectation and variance and value of n and p with the help of given expectation and variance, right? Now this is again as the similar one steps to solve the question. See, we are including this one because but again and again you will read the same statement, you will get the more clear concept behind the binomial distribution. So you can tell me how to solve this binomial distribution. You have to identify the binomial, right? You have to identify the outcome will be success or failure. You have to identify the n. You have to identify the independent trials. You have to identify the probability p, means success probability, and what is failure probability. And after that, apply the formula px equal to y. Right? And you have to suppose I gave the n value and probability x equal to y. For example, suppose I give the value this left hand side quantity, probability x equal to y is given, n is given, then you have to find the p. Then by this quantity you can find the p. Are you getting my points or not? Hello.
Yeah, yes, sir.
Yes, sir.
Okay, you are getting?
Yeah.
Suppose I gave the quantity of left hand side and gave the quantity means a value of n and I and ask about the value of p. Then by this equation you can find the value of p.
Yes.
Yes.
Okay.
Yes,
So
sir.
next, yeah, that is the next question. So you can try. Just try to think. You have to given the PMF values and you have to find a success probability. So by apply this quantity, you can find this value of small p. Okay, let's do. Yeah, hello.
Yes, sir.
Yeah, to solve it. There are
Yes.
70 responses. So I think we can wait for 1 more minute, and after that we can see the solution. You got the point how to solve this question, right?
Yes.
Sir. Yes.
Okay, then nice. Actually, if you remember that there is similar question I think, in the graded of week 11 to this question. Have you saw the graded one?
Yes,
No,
sir.
sir, I didn't get it, but now I think I can. At that time, I didn't get how to solve it, but now I
Okay,
think
okay.
now I can.
Yeah, there was. That's why we are conducting the solve with the session, so that you can solve with us. With you can
And
discuss the concept. We can discuss the questions. Okay.
I
And
tried to solve this question twice, but both time I got a different answer, so I'm not sure.
okay,
My
no worry.
answer
We
is
will do. We'll do. No worry about that.
In activity, I think There is also
Actually,
question like that.
easier easier approach for this kind of question is, we'll discuss. I think we can see the responses. Let me see how many of you are given the. Okay. Again, variations. I think you are not get the point. See, you have to just find the p here. Okay. And you are given the values of x and PMF is PMF of the binomial random variable for the each value is 0, 1, 2, 3, and 4. Okay. Now you have to find the p. See, you can see for in such type of question, you can start from this 0 value or this last value means fourth value. In that situation, your one quantity will become 1. Means, see, if you start from the probability x equal to 4 is given, it's 0.0256, right? In that situation, if you applied the PMF, then this 1 minus p quantity will become 1, right? And this NCI quantity also became 1. Then in that situation, you have only this p raised power 4. Then you can solve in easy way, 0.16. Right?
Yes, sir.
Yes, sir.
It's clear to everyone. Similarly, if you see, if your approach was, see, let me do this. Suppose probability x equal to I is given, okay, which is NCI p raised power I and 1 minus p raised power n minus I. Okay, suppose, and I is your 0 to n. Okay, for example, and suppose I am asking, tell me the probability value of this p. So, see, good approach is this. Either you can start from 0, 1 or last one. Suppose I start from 0, 1. Then what will be the value? Suppose I start with 0, 1. This quantity is given. So it will be NC0. Okay. P raised power 0 and 1 minus p raised power n minus 0. And suppose value is given, for example, 0.2. Okay. Value of this is given 0.2. You know this quantity will become 1. N factorial divided by 0 factorial and n minus 0 factorial will be, it will become 1. Okay. And something power 0 is also 1, right? Then these two quantity will become 1. Then what is this? This is 1 minus p raised power n equal to 0.2, right? Now you can solve this one. 1 minus p raised power 0.2 raised power 1 by n, and you will get the value of 1 minus p. After that, you will get the p is equal to 1 minus this quantity, right? Similarly, suppose I apply start from this n value, then it will become NCN, see, p raised power n and 1 minus p raised power n minus n equal to, suppose probability is 0.3. Then this quantity again become 1 into this p raised power n, and this quantity become 1 because it will be 0 and something power 0 is 1, then 0.3 and p raised power n is 0.3. From here you can get the value of p. That's it. Okay. Is it clear to everyone?
Sir, is it always that both the answer will be the same?
Yeah, answer will be same.
Okay,
Because
then
see,
I might have made some calculation.
yeah, see, if you see in this one, your p square is 0.6, then p will be 0.04. Right? And in this one, if you see 1 minus p is 0.6, then p is 0.4. Okay.
Okay.
Then see, here is the alternate method. Alternate method is nothing but you can apply the expectation of x is np, and by expectation of x, you got the this. See, you have 4 values. 4, that means 0 into that probability plus 1 into that probability plus 2 into corresponding to probability 3 into corresponding probability plus 4 into corresponding probability, you will get 1.6. You will get 4 into p 1.6. Okay. Then find the variance and see. One second. See. No need to find the variance. See, you get the 4 into P is equal to 1.6, right? Then you can get the P is equal to 1.6 divided by 4, which is nothing but 0.04. It's 2.4. Yeah, 0.04.
0.4 है.
0.4 only, sir.
Yeah, 0.4. Yeah, 0.4.
Sir, if there are, for example, there are 20 or 25 given probabilities, so this method would be very lengthy. So is it always that we need to calculate for all 25
No.
results?
See, suppose you are given this 25 probabilities, right? Okay. That's why I did for n. Okay. Suppose you have 25 probability and you start from the 0, it will be 25C0. P raised power 0, 1 minus P raised power 25. Suppose probability is given 0.2. Then it will become 1 minus P raised power 25. Now you can find the value of P.
Yes.
Or you can start from this one, 25C5, 20C25, P raised power 25. 1 minus P raised power 25 minus 25, it will become 0. Then 25C 25, it will be 1. And P raised power 25 equal to 0.3. So don't go with this one. I took the value randomly this. Okay.
Okay.
Got it? In this type of question, you can start from 0, 1 or last one. Because in that case, your one quantity will become, these two quantity will become one. You will be left only one quantity, and that will be easy to solve the question. Is it clear to everyone till now?
Yes, sir. To me, it's clear.
Okay. And you got this concept, how to you can see this expectation things become lengthy when it become 10 values, 11 values kind of. But this is also a good approach, right? Yeah, you know the formula for variance, see, you know what is variance? Variance of binomial is n into p into 1 minus p, and you can use the value of variance and n to solve the unknown value of p also. Similarly, in the previous one, we solved the question for p given n and expectation. Is it clear? See, in the previous one, we find the expectation, okay, and your n is given, and by this help of n into p, suppose we got the 1.6, then we got the value of p. Similarly, you can do for the variance also, right? Suppose your variance is given and n is given, then you can find kind of things. Okay? Just try to yeah, yes, this is the given, and yeah, solve this one. I think this is a very easy one. You can easily solve this one. I think 4 to 5 minutes will be more than enough to you.
Excuse me, sir.
Yeah, please.
Sir, there are many students who are not able to join. Those who doesn't have the student email ID and wants to join, and they are seeking for your help to resolve this issue.
I have no, in the chat I have given the link actually.
Okay, sir.
Okay, you can
Okay.
copy and paste. Yeah,
Thank you, sir.
yeah, thank you. Okay, so I'm hoping all of you were able to solve the question this one.
Yes, sir. Already, sir.
Okay, let me see the responses. I have see link is given in the chat. Yeah, so values of a lot of variations 0.4, 0.6 is same, but here is variation 0.24, 0.66. Why you are not able to join? No, I think link is given in your calendar, right?
Yeah, in calendar it is.
I think there is some issue, so you can. I think you can ask with support team. I think it's an issue for most of the people. Okay, so
Sir, the
till now.
problem is that we are able to join only via the Google ID what we have, what is provided from IIT Madras. From our personal ID, we are unable to join. I was
Yeah,
late for
that
10
is
minutes.
that can be issue, actually. Yeah, you can join by the IITM degree. Okay. So yeah, in this question, variance is given and n is given. So you have to just find the probability p. Okay. Your n is given. Variance is nothing but which is 1.92, right? So n into p, 1 minus p is given, which is 1.92. 8 into, so you can replace n by 8, which will be 8 into p into 1 minus p, which is 1.92. If you divide by 8, this one will be P into 1 minus V, which is nothing but 0.24. You can solve this equation. Okay, that is the easy one. And see, 0.24 can be split into 0.6 into 0.4. Okay, and you can write it see, P square 0.6P minus 0.4P minus 0.6 into 0.4 equal to 0. Okay, see, this P can be written as 0.6P minus 0.4P, right? Hello.
Yes, sir.
Yeah, you got this point. How to split this P and this 0.24? Okay.
Yes, sir.
Yeah. Then see, this first two quantity P square minus 0.6P, P is common, then it will become P minus 0.6P, then minus 0.4 is common, then P minus 0.6, and you will get the two values of P, 0.4 and 0.6. See, both are correct, because if you put the 0.4, then you will get 1 minus P as 0.6. If you put P as 0.6, then you will get the 1 minus P as 0.4. And in both cases, you will get the same variance. Right?
Excuse me, sir.
Yeah, please.
Sir, in the fourth line, it is P is the common and P minus 0.6 could be there, or P minus
yeah, it's 0.6.
Is it a mistake, or
it's a mistake.
Yeah.
It's a mistake.
Okay.
Actually, when you will take the P as common, then it will be P minus 0.6, not 0.6P.
Yeah.
Right? It's by mistake, I think.
Okay, that's okay, sir. That's okay. I just got confused on that.
No. It will be only P minus 0.6.
0.6.
Okay. Yes. So till this point, all the concept you people got it, right?
Yes, sir.
Okay, so thank you everyone. It was there was only 5 questions till now. So any one of you first tell me, you got the concept of these 5 questions, how you have to identify the binomial, how you can find the probability with PMF, how you can find the value of N and P with the help of expectation and variance, how you can find the value of probability with the expectation, how you can find the probability of P or N with the help of given the variance things. So these 4 or 5 things are used in the binomial things. That's all for a binomial. There is not much more of this. You have to apply just these 5 no, 4-5 concepts behind the binomial distribution. So any one of you have any question regarding, or we can close if you want, so you can ask, otherwise we can close this session.
Sir, I have a question from a different week. May I ask it now?
Which week?
From a different week, I have a question. Actually, I am attending the live session for the first time. Since I'm working, so I'm not able to attend frequently live sessions.
Okay. I'm asking about which week?
It's in week 6. That may
Okay.
be a very basic question, but I didn't get it.
About what? I mean, activity, practice, graded.
It is activity question.
Week 6, right?
And it is in the 6.1. And it is the first question. I didn't get how the answer is 729. That system says it is 729.
Okay, what is the question?
In how many ways the test paper of 6 questions can be attempted, each question being true or false type.
Okay, you got the answer as 36.
I'm getting answer as 64, but it is 729.
Okay. How you got 64?
Sir, because each question has 2 answers possible. It has a true or a false. And so 2 to the power 6 is 64.
Okay. So in the question, it was asking about 6 questions paper of 6 questions can be attempted, right?
Yeah.
Okay, so you gave the quiz to exam?
Yes.
Okay, how many questions were there?
Sorry, I don't remember.
Okay, it's all I think around 19.
Okay.
Including EMQ. Okay, see. So can you tell me, suppose in how many way you can attempt this paper of 19 questions? Either you can attempt, means you can suppose all the questions are of no, true false type. Okay. Then you have how many possibility you can attempt, means you can tick true or false, or you can does not tick no, you did not tick the option.
Okay, there is an option of not choosing it.
Yes, because it's asking about attempting. Suppose I goes in the exam center and did not tick any of the options, but I attempt the question paper.
Okay. So not giving an answer is also attempting it.
Yeah. There is another possibility. Suppose I did not take any of the option, then I have three possibility: true, false, not attempting.
Okay.
So it will be 3 responses.
Okay, I got it. I was missing the third one.
Yeah. That's, see, in the permutation combination, actually you have to think what possible cases will be there. You have to think all about all possible cases.
Okay.
Anyone else? Any doubt regarding week 11 kind of things? If you have, you can ask. Otherwise, we can close the session if you don't any doubt. Anybody? Regarding week 10, week 11 kind of activity, practice, anything? If you have doubt.
Excuse me, sir.
Yeah, please.
From week 10, activity question 10.5, question number 3.
10.5. Okay, let me open. Okay, what is the 10.5 you are asking about, right?
Yes, question number 3, sir.
Okay. Okay, this one, the variance of a number of tickets sold in a day in an opera theater is 25.
Yes, sir. The same question.
Okay. Okay, so in the question is given that variance of number of tickets sold in a day means variance of that number of tickets sold in a day is given, which is nothing but 25. Okay.
Yes.
Okay. My screen is not visible, right?
Yes, your screen is not visible, sir.
Okay, I thought it's visible. Okay. See. The question, if you see, what variance is given? Number of tickets sold in a day in an opera theater is 25. Okay. Suppose what can be your random variable? Suppose X is my random variable, which is number of tickets sold in theater in a day, right?
Yes, sir.
Okay. And variance of these things is given, which is nothing but 25.
25.
And what is the question? If for each ticket sold, the profit obtained is 25 rupees, then what is the variance of the profit obtained in a day? See, you are asking about the profit, and in the question for each ticket sold, profit is 25. That means for one ticket, you got the profit of 25 rupees. For two ticket, how many profit will be?
50.
50. That is 2 into 25. For 3 ticket, it will be 75. For 4 ticket, it will be
100.
For X ticket,
X into 25. So it's just a multiplication with that variable.
You have to find the variance of 25
there is no
times
change in that variance like that.
No, variance will be changed.
See, okay, for addition only there is, sorry.
Yeah. What? So just tell me, what will be the value of this? It will be 25 square into variance of
25.
Yes, it will be 625
into 25.
And what will be value of this? This will be the correct answer.
Okay,
right?
sir. Okay, sir.
It's
Thank
clear?
you. Yes, sir. Sir, one more question, sir.
Yeah, from which?
Activity 10.6, the question number 3.
Okay.
Maybe
Okay.
the same variance problem, I think so.
Yeah. X, Y, and Z is given. Okay. Y equal to 2x and X and Z are independent. Okay, variance of X is 2 and variance of Z equal to 7. Then standard deviation of X plus Y plus Z. Okay, see. You have to find the standard deviation of X plus Y plus Z. Okay.
Yes, sir.
Which is nothing but square root of variance of X plus
Y plus Z.
So just see in the question variance is given. So just find the variance, right? Which will be easy for us also. Okay. And if in the question, if you say y equal to 2x is given, so just put the value of y is equal to 2x. That means x plus 2x plus z. It will be variance of 3x plus z.
Okay.
What will be? And you know, in the question, it's mentioned that x and z are independent. If x and z are independent, then variance of x plus y is equal to variance of x plus y. You know these things. Okay.
Where x plus
yeah. When this quantity will be equal to this, then x and y are independent. So it will become 3 times variance of x, right? Right or wrong?
Correct, sir. Actually, I
wrong.
take it as
See. It will become 9.
3 square. 3 square, and then here 2.
No, it's z.
Variance of okay.
So 9 into variance of x is 2 and plus 7. So it will be 25. So standard deviation of x plus y plus z will be
square root of 25. That is 5.
Right.
Okay, sir. I taken as variance of y is equal to variance of 2x like that. But why that answer?
See, if you took there is no information about y. Means it's not given that y is independent of x and z are independent.
Okay.
It's clear?
Okay, sir.
Okay.
Thank
Anything
you,
else? Anybody?
Thank you, sir.
Okay. Any question regarding week 11 or thing? Or I think we can close this session. Ravikant has asked 12.2 question number 9. Okay, you are watching week 12 session, right? Hello, Ravi?
Yes, sir.
Okay, see. Let me share my screen. 12.2. Yes, this. Okay. Okay, so for that random variable finally distributed this. So what was your approach, Ravikant? I think you have asked on discussion or discourse, right? This question was.
No, sir.
Okay, see. First solve this question, okay? What will be this this equation? It will be x square plus 10 by x greater or equal to 7.
Yes.
Okay. It will be x square plus 10 greater or equal to 7x.
Yes.
Then x square minus 7x plus 10 greater or equal to 0.
Yes.
Okay. Just tell me. Okay. Can I write it? 2x minus 5x plus 10 greater or equal to 0?
Yes.
Okay. That's why if you multiply it by 2 minus 5, it will become 10. This is nothing, just a simple mathematics of quadratic equation, right? Then from here you can take x as common.
Mistake on now I can get it.
Okay. It will become x
Yes,
minus
sir,
2
Clear.
Okay. Now you can proceed further. How it will be, in which case it will, both quantity will be greater or equal to 0. Then apply the concept of x follow uniform. I think it's 0, 10. Then apply the PMF. Okay.
Okay, 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 sir.
Okay. Now you can do, right?
Yes, sir. Yeah.
Okay.
Actually, I have made some calculus mistake. That is why.
Oh, no worry. Okay. Anybody, anything else? Or if you have any doubts, so you can ask. Otherwise, we can close this. I think too much silence. Okay. So bye bye everyone. Thank you.
Thank you, sir.
Thank you.